So we are going to look at some other parent functions. So we talked about parent functions at the beginning of the year, and we did a bunch of transformations. Those definitely aren't all of the parent functions that exist ever, but doing them all at one time at the beginning doesn't always make a whole lot of sense. So we're going to talk about the reciprocal and the reciprocal squared parent functions today. So reciprocal parent function looks like this. F of x equals 1 over x, because it's a reciprocal, right? And when we go to graph this, okay, so let's think about this. Substitute some numbers in. So if I substitute 1 in, 1 over 1 is 1. So I'm at 1, 1. If I substitute 2 in, that'd be 1 over 2, get me 1/2. If I substitute 3 in, that's 1 over 3, that gives me to 1/3. And my board has not been happy about me trying to make points today, so I don't have a clue what's going on, but it thinks I'm pushing the button even when I use a different pen, and I'm not, so then it does this. Okay, so I think I might have to put I'm going to put little X's where the points go. They're just points, but if I try to make a point, it's going to be a hot mess. So I'm going to put little X's there. It doesn't mean anything special. When I substitute in 4, it's going to get me to 1/4, which is going to be like right there. Okay, I will go grab my other pen. Is there an X value? So I'm getting my Y values are getting closer and closer to 0. Is there an X value that exists that I could substitute in that would give me 0 for the Y value? What do you think? Because the bigger my number gets, the smaller the fraction is going to get. Is it going to get down to, am I ever going to actually make it to 0? No, okay? So you can think about it this way. If I'm going from me to that table right there, I can cut the distance in half. I can cut it in half again. I can keep cutting it in half, and physically I'm going to touch the table. But theoretically, do I ever make it to the table? No. I get really, really close, but I don't actually make it. So as x increases and y decreases, that's what's going to create this horizontal asymptote here. So it's never actually going to hit 0. It's just going to get closer and closer and closer into where it kind of looks like it kind of has to. Earbuds out. So then if I start to get, so let's do something less than 1. So let's like put in 1/2. What's 1 divided by 1/2? 2. So 1 over 1/2 is 2. So 1/2 I'd be at 2. At 1/4, or at 1/3 rather, I'd be at 3. It's not happy with this either. Okay, and so forth. So I know that there is not I cannot substitute in 0 for x because 1 over 0 is undefined, and that's what creates this vertical asymptote right here. So this part of the function looks like this because this is the only thing that's going to make sense when you have asymptotes. Sorry, my hand was in the way. I can't. It's going to look something like that. Okay. So then if I do my negative numbers, well, let me tell you this first. There's only, even though we plotted a bunch of points because I wanted you to see what was happening there, there's only 3 anchor points on that part right there. We'd have 1, 1, we'd have 2, 1/2, and we'd have 1/2, 2, and then you can sketch in that shape, okay? So if I substitute in a -1, it's going to give me a -1. -2 is going to give me -1/2. -1/2 is going to give me -2. Then those 3 points are enough for me to get this shape in here like so. Okay? Everybody understand what's going on here? So this is our reciprocal function, 1 over x. The type of graph, yes, it's a reciprocal function, but that's not what we put here. This is a rational function because I have variables in the denominator. I don't have any in the numerator, and that's okay. So we don't have to, but they have to be in the denominator. My domain, is my domain all real numbers? No. I start at -infinity. I get to use all the x's until I get to 0, but then I have an asymptote, so I have to start over on the other side of that and go from 0 to infinity. My range, also not all real numbers. My range starts down here at -infinity. I get to use all the y's until I get to 0. I have an asymptote, so I have to start back over on the other side of 0. It looks like that. Left to right, bottom to top, always least to greatest. All right, so then I have a vertical asymptote and a horizontal asymptote. Anytime you're asked for an asymptote, they are lines. You write them as equations of lines. So I can't just put a number there. So this is my vertical asymptote. Is this an x equals or a y equals line? X equals. Vertical is, bless you, x equals 0. My horizontal asymptote is y equals 0. If you get those mixed up, which at this level we shouldn't be getting that mixed up, but if I write a lowercase cursive y, maybe that's not how you actually write it, but that's how it would look in a handwriting book, right? And then you rotate your paper around 180 degrees, it's going to look like a lowercase cursive h. So y is horizontal. Connect those two together. If I take x, if I rotate that 180 degrees, it's still going to look like x. But if I chop it in half, it makes a v, x is vertical. Whatever you got to do to tie it together in your brain so you don't mess up on something like that, because it's very simple, it's going to come up a lot, and it can really mess you up if you get them backwards. Okay, we good? All right, so let's look at the reciprocal squared function. This one is f of x equals 1 over x squared. So let's plot some points here. If I substitute in 1, 1 over 1 squared is 1. If I substitute in 2, 1 over 2 squared is what? 1/4. Boy, here we go. 1/4. If I substitute in 1/2, 1 over 1/2 squared is going to be 1 over 1/4, which is 4. So those are those 3 anchor points. Here's my function. Because the same things are happening, I can't substitute in x, it's undefined, and there's not an x value I can substitute in to get a y that is 0. So I have, once again, for my parent function, the asymptotes are on the axes, which is going to become very helpful to us when we start graphing. So then I substitute in -1. 1 over -1 squared is 1. 1 over -2 squared is 1/4. 1 over -1/2 squared is 4. So this is what your reciprocal squared parent function looks like. Has the same basic shape as the reciprocal function, but it changes faster because it's being squared. And also all of your y values are positive because we squared it, so it kind of reflected that one piece up. The type of graph here, this is still, again, a rational function. My domain is the same as it was for the other one, -infinity to 0, and then 0 to infinity. Where does the range start? 0, so we go from 0 to infinity. Left to right, bottom to top. Do not put things like infinity to 0 because that makes absolutely no sense. All right, then my vertical asymptote, once again, is at x equals 0. My horizontal is at y equals 0. Okay. Any questions on that? All right, so let's talk about transformations. All right, so my standard form for my reciprocal functions, although the transformations that we do, it works the same on every single graph. The C is, is the C, the D is the D, and those sorts of things. But it looks different here because it's in a fraction. So usually A is what we write first, right? We start with the A. Well, we can put the A out front, but it really goes in the numerator. I mean, it's the same thing, but just kind of how we write this. So A up here, and then B times x minus C in the denominator, because the C and the B both affect the x, right? And then plus D. The reciprocal squared function with the transformations looks like this. A is in the numerator again, but then we have B times x minus C, and all of that has to be squared in the denominator, plus D. So again, not changing what these things do. I could change the letters even, but it's where the letters are that make the difference. So this C here, is this C going to be something horizontal or vertical? horizontal because it affects x. So c is the horizontal shift. If it's x plus c, which way do I go? Left. And if it's x minus c, I go right. Okay. When I have the plus d, that's going to be vertical. So plus shifts up, minus shifts down. Remember, so x is still a liar. That doesn't change either. Since A is actually usually out front, and again, we could write it that way, we just don't, then that means that it affects the y, so it is vertical. It is our vertical stretch or compression. And B is the horizontal stretch or compression. So if A is negative, so if I'm going to multiply by a negative, I know that that gives me a reflection. So if A is negative, the function is reflected. But would it be reflected across which axis if A is negative? Does that negative, okay, let me ask you this then. If B is negative, this down here, the negative would affect the x, which means it's a reflection in y, right? So if the A is negative, then it's a reflection in x. So if I feel like if this was written out like a polynomial, I don't think that that would be a question for you. I think you know it's supposed to be reflected in x, but I think that when it's in the fraction, it looks a little bit different. It's weird. So if you're not sure about one, think about the other, and if the other one makes more sense, then you know which is which. So this is just like having a negative way out front, and that's when we reflect it across the x-axis. And if B is negative, then it is again reflected, but this time across the y-axis. Because remember, we change the sign on y, it reflects in x, change the sign on x, it reflects in y. Okay. One more thing we can get from this, so like all that's just a review. All that is the exact same thing that's been happening with everything, but we can get our asymptotes from this as well. So if you look back up here at these graphs, if I reflect this graph either in the x-axis or y-axis, does it affect the asymptotes? No. If I take this graph and I vertically stretch or compress it, does it affect them? No. If I horizontally stretch or compress it? No. If I shift it left or right, does that affect the asymptotes? Yes. If I take this whole thing and I shift it left or right, the asymptotes are going with it, right? And if I shift it up or down, same thing. So if the only thing that affects my vertical asymptote, I can shift it up and down all day long, it doesn't affect the vertical asymptote, but if I shift it left and right, it affects where this one is, because we're starting at 0. Same thing with the horizontal. So since the translating left and right is what's going to affect my vertical asymptote, if this was x plus 5, that means I shift to the left 5, so my asymptote would be x equals negative 5, right? So your vertical asymptote is just x equals c, whatever that is. Your horizontal asymptote, same thing. If this was plus 4, I'd go up 4, so would that asymptote have to go up 4. So your horizontal asymptote is just y equals whatever t is. Okay. What questions you got? All right. Then let's look at writing some of these, and then we'll graph a few. So we have the reciprocal function, the reciprocal parent function. So that means that my parent function f of x equals 1 over x. Okay, so that's the one I'm using. It's reflected across the x-axis, so I'm going to have a negative somewhere. Translated 4 units right and 3 units down. So there's 3 things I have to make sure I take care of. And then I'm supposed to write the equation, and then identify the asymptotes. So since I called this f of x, I'm going to call this g of x. So I have a fraction. It's reflected across the x-axis, which means the negative is in the numerator. A is 1, so this is just a negative 1. Translated 4 units right, so this would be x minus 4 in the denominator. 3 units down, so it would be minus 3 on the outside. Okay? Everybody understand where everything came from? So then I have to identify the asymptotes. So my vertical asymptote is going to be x equals what? 4. And my horizontal asymptote is going to be y equals -3. Okay. Any questions on that? All right, so let's look at the next one. The reciprocal squared parent function. So f of x is equal to 1 over x squared. It is vertically stretched by a factor of 2, translated 7 units up, and 1 unit left. All right, so g of x is going to equal, I have a fraction. All right, so vertically stretched by a factor of 2, that's the a, so that's in the numerator. Translated 7 units up, so this will be plus 7 out here. 1 unit left, so this will be x plus 1 down here, but then this has to be squared because it's the reciprocal squared function. Everybody okay with where all that came from? All right, so then my vertical asymptote, what's the vertical asymptote here? Close. X equals -1. Remember, it has to be an equation, so yes. -1. Oh. -1. There we go. Horizontal asymptote is what? Y equals 7. Good. Okay. Any questions about any of that at this point? We good? I mean, the transformations you should have down by now, like what does what, and then you just have to be able to apply it to other functions. All right. Oh, I'm sorry. Go ahead. No, because this is always x minus c. Does that make sense? Yeah. Because x is a liar. X is still a liar. Liar, liar. That's right. Okay, so we're going to adjust how we graph these just a tiny bit. It actually makes it easier when you have asymptotes. And the very first thing you always want to figure out and graph are your asymptotes. So for the parent function, so the parent function looks like this. So for the parent function, I have x equals 0 and y equals 0. So I have to decide, are those my asymptotes or do they change? Okay. So does this get shifted left or right? No. So that means that asymptote that's at x equals 0 is still at x equals 0. But it does get shifted down, right? So the horizontal asymptote that was at y equals 0 gets shifted down. So now that's at y equals -2. So then we want to graph those. I have x equals 0 and y equals a -2. So when you do that, you can make those, since they used to be on the axes, right? And so basically treat this as your new x and y axis. And I'm just going to graph off of that. Pretend like this is my 0, this is my new 0, 0. But then I ignore the fact that I translate down to, because basically it's already been translated down for me. So I'm really just graphing this 1 over x, which means from 0, 0, I had 1, 1. Oh, here we go again. I had 1, 1. And then if I substituted in 2, I got 1/2. And if I substituted in 1/2, I got 2. So those are my 3 anchor points there. Do you understand how I just changed where my axes were? It's the easiest way to do these. Then I'm just going to sketch in my graph. Right. Which means then over here I have -1, -1, -2, -1/2, -1/2, -2. Sketch that in. Then I can write my domain. My domain doesn't change from the original because the left and right is what affects that. So -∞ to 0, and then 0 to infinity. The range does change though. I go from -∞ to -2, and then -2 to infinity. What questions you got? And notice how these are related to each other, right? Okay. We good? Any questions? Alrighty, so let's look at number 6, which is a reciprocal squared. So my parent function looks like this. To figure out my asymptotes, I still don't go left or right any, so vertical asymptote is still at x equals 0. I do go up 1, so my horizontal asymptote is at y equals 1. Okay, just pulling those straight from the equation. Then I'm going to graph those, so I got x equals 0 and y equals 1. So then, those are my new x and y axis, so I ignore what I used to get this, basically. So I'm really just graphing this negative 4 over x squared. So it's the reciprocal squared function, but my transformations then are, I'm going to reflect it in the x-axis, in my new x-axis, which is my asymptote, and I have a vertical stretch of 4. So for the parent function, I'd be at 1, 1, which will be right here. I reflect across my new x-axis, and I'm 1 away, so that means I have to multiply that by 4, so it becomes 4 away, and I get that point right there. So the next point I would have would be 2 1/4. So I would reflect in my new x-axis. 1/4 times 4 is 1, so it just becomes 1 away from there. My third anchor point would have been at 1/2 4, but then once I reflect and I stretch, I'm way off my graph, so it's not even worth it. I got those two, and because I know what the shape's supposed to be, that's good enough. Although I totally missed those points. Let me try that again. More like that. So then to get the other piece is just reflected across the y-axis here. Okay. And who sent you back with that? Yeah. Okay. There's no time on that. Okay. All right. So then this point reflects over here. This point reflects over here. Oh, I missed it again. Okay, like so. Okay. Everybody good so far? So my domain, negative infinity to 0, and then 0 to infinity, and then negative infinity to 1. Open, open, because you don't actually make it to the asymptote. Okay? What questions you got? All right, let's look at number 8. So here, I do go left or right, because there is a horizontal transformation here, which means my vertical asymptote is at x equals what? Negative 4. And then my horizontal asymptote is at y equals negative 7. Okay. So once I do those, this is just a reciprocal function. That's my parent function. I'm going to ignore the 7 and the 4 because basically I've already used them once I graph them. So I go to negative 4, here's my asymptote, and negative 7, here's my asymptote. Okay. So once you graph them, ignore what you have, and then we're really just graphing 2 over x using our new x and y axis. So I start here at 1, 1, but I have a vertical stretch of 2, so I go 2 away, which is right there. Then I would go to 2 1/2, but 1/2 times 2 is 1, so I'd end up right there. Then I'd have 1/2 2, but I multiply that by 2 and I get 4. There we go. So I can sketch this in. Then I got to do the other piece. So it'd be at -1, -1, but I multiply that by 2. It only goes 1 off the graph, so I'm going to go ahead and plot it. Oy. No idea what it thinks I'm doing. So I'm right here. There we go. Then I do -2, -1/2, but then multiply that by 2, so that becomes -1. And then the other one's just going to be way too far off, so I'm going to have that. Then your domain, -infinity to 0. No, it's not. It's -infinity to what? -4. And then -4 to infinity. Then my range is -infinity to -7. And then -7 to infinity. Okay. What questions you got? Good? All right. So we are going to do one more. We're going to do number 9. What is my vertical asymptote? X equals 5. And my horizontal? Y equals 3. Good. You get that one graphed. While I hand out the assignment, then I will graph it, and we will talk about the assignment. So when you're done, check yourself with me. Let me know if you have any questions. If you don't have any questions and it all makes sense, then go ahead and fold and tape. Yay. I just realized I used the wrong points. I wasn't paying attention to what I was doing. So let's back this up. Remember, if we don't match, don't always assume that you're the one that's wrong. If this isn't your question, then I will still answer your question, but let me fix this first. Okay. Yeah, well, that's why we should watch the whole thing. Okay. So, yeah, and I even drew it. I don't know what the heck I was doing. So 1, 1 is still that, and then I reflect. Okay. So then I do 2, which would be 1/4, and then I reflect, and it's right there. And those probably don't look that much different. But 1/2 would put me at 4, and then I reflect, and I'm right here. Oy. It's going to flip out again. Okay, so 1, 2, 3, 4. Be right there. Except I can't. It does not want me to make points. 1, 2, 3, 4. There we go. And then I just reflected over here. Is that why you were asking a question, or do you have another question? Okay, that's fine. I'm glad you asked because it made me catch this. Is that what I had? This is what I had? No, it's not what I had. Okay. Now I'm second guessing my second guessing. I don't even know. Okay. All right, so do we understand why that's correct? Okay, now ask me your question. Sorry, go ahead. Right, so if I substitute in 1 to the, it's all about the parent function. It's 1 over x squared. So if I substitute in 1, I get 1. If I substitute in 1/2, I get 1/4. If I substitute in 2, I get 1/4. If I substitute in 1/2, I get 4. It's your anchor points. If I substitute 1/2 into this, 1 over 1/2 squared is 4. It's the parent function. Okay. Anything else? We're good? Okay. All right, the assignment you have, you're only doing 1 through 10.